All right, so today we're going to talk about solving systems of linear equations with 3 variables. How many variables have you guys been using so far?
2.
Just 2, right? Ax plus by equals c. So when you had 2 variables, you had to have 2 equations in order to solve it. And your answer was an ordered pair, x and y. When you've got 3 variables, that means you have to have 3 equations to be able to solve it. And your answer is an ordered triple, x, y, z. All right, so this next part is out of your book. I do not expect you guys to write down these pictures, but I just wanted to show you what's happening graphically. So when we have 3 equations, we're actually talking in 3 dimensions, and the graph of each of those equations is a plane. So again, if you want to look in your book at page 178, all of this is in there. But there's the 3 possibilities. There might be exactly one solution, and that's where the planes all intersect in one point. There could be infinitely many solutions. It means they could be intersecting in a line, or they could be the same plane. And it could be no solution, that there are no common points of intersection. Okay, but I'm not expecting you guys to draw these. But I just wanted you to see what was happening with these. So just like our 2 equations, it's very similar. You could have one, you could have infinitely many, or you could have no solution, right? That's still possible when we have 3 variables. Okay, so I'm going to do an example for you. We have 4x plus 2y plus 3z is equal to 1. 2x minus 3y plus 5z is equal to negative 14. And 6x minus y plus 4z is equal to negative 1. What we're going to do is we're going to use elimination, and we're going to create a system of 2 equations and 2 variables. So we're going to choose one of these variables to eliminate. So I think I'm going to get rid of some x's and then have 2 equations with y and z. So if I look at my first 2 equations, if I wanted to eliminate the x, what should I do? What should I do? Multiply the second equation by negative 2? Yeah, so that's what I'm going to do. I'm going to multiply the second equation by negative 2. So the first one stays the same. 4x plus 2y plus 3z is equal to 1. And then multiplying by negative 2, I get negative 4x plus 6y minus 10z is equal to a positive 28. So now when I combine them, my x's cancel out, and I have 8y minus 7z is equal to 29. So now I've got to combine 2 different ones to come up with another equation. So I could combine 1 and 3, or I could combine 2 and 3. And if I choose 2 and 3, then I only have to multiply one of them. So I'm going to choose these 2 to work together. So now what do I have to multiply that second one by to make the x's go away? I've got a 6x on the bottom, right? So what do I have to do to make the 2x turn into a negative 6x? Multiply by negative 3. So I'm going to multiply the middle one by negative 3. So I get negative 6x plus 9y minus 15z equals a positive 42. And then rewriting the other one under it, 6x minus y plus 4z equals negative 1. So when I add them together, my x's cancel out. 9y minus y is 8y. And then negative 11z equals 41. So now I have a system of 2 equations and 2 variables. You guys already know how to do that. And in fact, it's set up pretty well for elimination, isn't it? We got lucky on this one. So I'll go ahead and multiply this equation by negative 1. So I get negative 8y plus 7z equals negative 29. When I add those together, my y's cancel out. I get negative 4z is equal to 12, so z is equal to 3. So now what do you guys think I should do to figure out what y is? Anybody have any idea what I should do with that z? Plug it back in. Which one do you think I should plug it into? Like one of the original 3? Okay. The problem with that is there's 2 other variables in that. But don't I have a couple of equations with only z and 1 other variable? I do, right? I could plug it into this one, couldn't I? Yeah, so that's what I'll do. I get 8y minus 7 times negative 3 equals 29. So 8y plus 21 equals 29. When you subtract, you get that 8y is equal to 8, and so y would equal 1. Now that I have 2 of them, I've got y equals 1 and z equals 3. Oh wait, did I say 3 or negative 3? It is negative 3. I'm missing from over here. Okay. Now I can use any one of those equations to figure out what x is. So I'll just go ahead and use the 4x plus 2y plus 3z equals 1. And I'll plug in the 1 for the y and the negative 3 for the z. So I get 4x plus 2 minus 9 equals 1. That's a negative 7, so I'm going to add 7 to both sides. And I get 4x is equal to 8, and so x would have to equal 2. Alright, so now I've got all 3 of them. I should check my answers, though. So I'll at least check those second 2. 2x minus 3y, 2x minus 3y, plus 5z equals negative 14, plus 5z is negative 14. So I get 4 minus 3 minus 15 equals negative 14, and that works. And then the other equation that we had was 6x minus y plus 4z. 6x minus y plus 4z equals negative 1. So I put in my x, y, and z. 12 minus 1 plus negative 12 is negative 1. So you end up with negative 1 equal to negative 1. And it works. Oops, negative 1. Okay, so the way you would write your answer then is it's an ordered triple. So I write the x first, the y second, and the z third. And so this is your final answer, 2, 1, negative 3. Okay, questions? All right, so you can see they take up a little bit of space, and you need to kind of remain organized when you're doing these problems. So I don't think this is actually going to fit on your whiteboard very well. You might want to just do this one in your notes, okay? So what do we feel like getting rid of, x, y, or z? How many vote for x? How many vote for y? How many vote for z? Wow, how many didn't vote at all? How many are asleep? Okay. All right, well, I'm going to make an executive decision, and I'm going to say, let's eliminate y. Okay? So come up with 2 equations to eliminate y. So you could combine, for example, the first and the second, right? And that'll give you an equation. And you could combine the second and the third, and that would give you another equation. Okay, so when you guys combine the first 2, did you get 12x minus 3z equals, oops, positive 18, not negative 18? Did anybody get that equation? Yeah? Okay. And then I combined 2 and 3. Did anybody else combine 2 and 3? All right, did you get 13x plus 5z equals 3? All right, so now we're going to combine these two, and it's probably easiest to get rid of the z, so what would we multiply by? Multiply this one up here by 5 and this one by 3. Okay, so when I solved those two new equations, I got that x was equal to 1. So I plugged it into the 13x plus 5z equals 3, and I got z was equal to negative 2. And then I plugged both of those into one of my original equations, 3x plus y minus 2z equals 10, and I got y is equal to 3. So then you write it as an ordered triple, 1, 3, negative 2. All right, so let's take a look at this one and see what happens on this one. So I'm going to use elimination again. I'm going to combine the first two, and so I'm going to multiply this top one by negative 4. So I get negative 4x minus 4y minus 4z equals negative 12. And then I write the second one under it, 4x plus 4y plus 4z equals 7. So what happens here? Everything cancels out on the left, right? And I end up with 0 equals negative 5. Is that possible? No. So when that happens, you know that it's no solution. They do not have a single point in common. Okay? So that's one possibility. And I've got another example. This time I've got x plus y plus z is equal to 4. X plus y minus z is equal to 4. And 3x plus 3y plus z equals 12. So for this one, it's going to be really easy for me to get rid of my z's. So I'm going to combine the first two together. X plus y plus z equals 4, and x plus y minus z equals 4. When I combine them, my z's cancel out, and I get 2x plus 2y equals 8. Then I notice that I've also got a negative z and a positive z if I combine the second and third ones. So if I add those two together, I get 4x plus 4y, my z's cancel out, equals 16. So now that I have two equations, I can go ahead and multiply this one by negative 2. And so negative 2 times 2 gives me negative 4x. Negative 2 times 2y gives me negative 2y. And negative 16. So this time, what happened here? I get 0, 0, 0, don't I? So if 0 is equal to 0, what's that mean? That means there's infinitely many solutions. So that's what it's going to look like when it's infinitely many or when it's no solution. Okay. Any questions on those two? Alrighty, so I have one for you guys to try. Again, you can do it in your notes if you want. Alright, so I chose to multiply the top one by negative 2, and what happens? Whoa, undo, come back here. What happens? I get 0 is equal to 2. Is that possible? No, so that's no solution. Okay, do you guys want another one of these practice? No, you're going to save up for tonight?
How many do we have tonight?
Okay, so tonight you've got really only 6 of them that are this time. Yeah. Okay? All right. So what are our possibilities? I might have how many solutions? 1 or infinitely many or no solution. Alrighty.